All right, let's do that example that we didn't get to yesterday. Let me sign this pass first. You're welcome. All right, here we go. So I'm going to draw a kite. That's the last thing that we did yesterday. We're not going to fly a kite. We are going to draw a kite. All right. What was that? Somebody said something? Somebody asked me a question. What was that? Yeah, that's what we finished. But we're doing an example on a kite, though. Yeah, that's true. You're absolutely right. Trapezoid was the last thing we talked about yesterday. The thing before that was the kite. Thank you. All right. Trying to make those the same. That kind of looks the same, doesn't it? Let's push this up a little bit. This may not be drawn exactly to scale, but it's close enough for us. That's not too bad. All right, now here, if this is a kite, what's true? Yeah, they put letters in here, so let's do that. We'll call it L, K, J's down the bottom, and M is right there. All right, so tell me what things are equal to each other if this is a kite. Mar? Give me letters. LK and LM. So LK and LM are equal to each other. That's good. What else? KJ and MJ are equal to each other. So we put 2 ticks for these. The ones with 2 ticks means that they're equal to each other. The ones with 1 tick mark means that they're equal to each other. Everybody got that? All right. But what we're going to do, though, is we're going to put some letters in there, okay? We're going to do some algebra. We've been doing that all year, haven't we? Right? You do things with just numbers, right? This is equal to this. This is supplementary to this, whatever. But then they always put X in there, right? And then you got to set up an algebra equation. You got to solve for X. Then you got to plug it back in. Well, that's what we're going to do right now. I don't know if you remember me saying this, but when we first took geometry, I said, we're going to learn, I think probably the first time we did that, right? When you had something was equal to each other. You said, okay, this is 3x plus 5. This is 7x minus 2. Set them equal. Solve for X. Plug it back in. We've been doing that just about every single chapter, haven't we? We do that all the time. So this is really nothing new. The only thing that's new is the fact that this is a kite. We didn't know what a kite was until yesterday, right? At least a geometry kite, right? So that's really the only thing new. So what we're doing right here you should hopefully kind of understand the process, right? So it's the process that's the same. It's the particular pictures and shapes that are different. This is x plus 5, and this is 3x minus 1. So my guess is that many of you, if not most of you, probably could do this without any further explanation. And I'll tell you what, I'll give you a minute, 30 seconds on both of them. You should be able to do it, all right? So I'll give you 1 minute. Ready? Go. Solve for X, solve for Y. I said a minute. Solve for X, solve for Y. We'll plug it back in a second, but for the minute, just solve for X and then solve for Y. Do the X one first. That's the easiest one. I already gave you a big hint, didn't I? I said that they're equal to each other. So what are you going to do with x plus 5 and 3x minus 1? You're going to set them equal to each other. And then do some algebra. It's only a couple steps. Do some algebra and get x by itself. Then you're going to do the same thing with the y's. The y's are equal to each other. So you set them equal to each other. Do some algebra and solve for y. That's why it's so important to learn your algebra, because you use it, especially in geometry. You use it a lot. And you use it to solve for things. That's why we learn math in the first place. All right, I'll give you another 30 seconds. I'll get you started. So on the x's, you could go x plus 5 equals 3x minus 1. I'm going to go 3x minus 1 equals what? X plus 5. Any idea why I did that? Why did I put the 3x minus 1 first? You don't have to, but why do you think I did that? Okay, yeah, because the smaller number's on the right, the bigger number's on the left. It's just a little bit nicer. And then I can put my x's on the left-hand side. And when we learn algebra, most of the time we put the x on the left-hand side, didn't we? X equals something. Okay, it doesn't have to, but I did. All right, what's the next step? Once I get these equal to each other, what's my next step? Just pay attention. Oh my goodness. You guys done? In a second. In a second. All three of you, just settle down. Neil, what's my first step? Okay, how do I do that? I got to take this x and move it over here. How do I get rid of that x? Subtract it, right. So I subtract an x from this side, subtract an x from this side. Now, you could do the next step in the same step. That's what I'm going to do, all right? So now what do I want to get rid of? I got rid of the x, and I got the x's on the left-hand side. Now I have to get rid of what? Keep the 5 there. My x is on the left-hand side. I don't need to move this. The 1. How do I get rid of that 1? Yeah, add it, right, because it was being multiplied. It was being subtracted, so I add it. So I add a 1 to this side, and I add a 1 to this side. Okay? So this cancels out. This cancels out. And bring everything down. What's 3x minus x? 2x. What's 5 plus 1? 6. Next step is super easy. Divide by 2. Divide by 2. What's x? It's equal to 3. But that technically is not what they ask for, okay? What they want you to find, I didn't even tell you what they asked for, okay? But I did ask you to solve for x and y. So that should have been your x. Did anybody get that before I got it? Just one person? Did you get it? Okay. Mine, did you get it? Okay. So that's what x is. Let's do y, and then we'll talk about what we're really trying to solve for. Let's do the y. So what do we do with this? We're going to take those and set them equal to each other. Now again, you don't have to do this, but I do it just because I like the bigger number on the left-hand side. So what's going to go first here? 5y plus 2. And you're going to set that equal to what? 3, parentheses, y plus 2. Okay? And now we got to solve for y. Now, we're not going to subtract anything just yet. We're going to do one thing that we didn't have to do on the first one. What's that? Distributive property. I love it. Distributive property. So you're going to distribute the 3. Okay? So let's do that. 3 times y is just 3y. Then 3 times 2, positive 3, positive 2, plus what? 6. Now, it looks almost identical, right, to the one that we did earlier with the x. Would you agree? So I'm just going to do it quickly. Subtract a 3y from both sides. Now, you could bring everything down right now, but I like to get rid of the other stuff. So I subtract a 2 from both sides, right? You know the 2 and the 2 cancel. The 3y and the minus 3y cancel. 5y minus 3y is 2y equals 6 minus 2, which is 4. Divide by 2. Y equals 2. Now, I went through it pretty quickly, but this should be almost second nature to you. Would you agree? For a lot of you, it is. No, for some of you, it's not. All right? But again, that's why we took 2 weeks in the middle of the year to just do algebra so that we could do stuff like this, because I knew this stuff was coming up, right? We've used it in the past. We're going to use it in the future. We're using it right now. So, is that what they asked for? No, I didn't even tell you what they asked for. Here's what they asked for. They say find basically all the missing sides. So what are my missing sides? Well, LK and what? LM. That's not an angle. That's supposed to be an L. Kind of looks like an angle, but it's an L. All right? And then what else are you going to find? KJ and what else? MJ. Michael Jordan. All right, there you go. All right. Let's do this. I just want to put these underneath each other. All right, so what are we going to do? Let's do the x first, okay? Remember we said x is equal to 3? So how do I find what kj is equal to? Just do what? What's the phrase I use all the time? Just do what to it? Plug it in. That's right. We're going to plug it in. All right, so we're going to plug in the 3 for the x. So instead of x plus 5, it's what? It's 3 plus 5. What's 3 plus 5? It's 8. So kj right there is 8. So what's mj going to be without doing any math whatsoever? It's going to be 8. How do you know that? How do you know that mj is 8? Because they're equal to each other. That's right. Okay, you don't even have to go through the math. What if you wanted to go through the math? Let's just do it very quickly. So this is going to be what? 3 times... It's not 3 times 1. It's 3 times 3, because it's 3x minus 1. 3 times 3 is 9. 9 minus 1 is 8. It does work, doesn't it? But did you have to do this? You didn't have to, because you know they're equal to each other. Once you find one, the other one's going to be the same. Same thing here. All right? What do you want to put the y? What did we say y was equal to, by the way? Y was 2, correct? I'll write it right here. So y was 2. You could put it in for this one. That'd be fine. Or you could put it in for this one. That'd be fine. It doesn't matter which one. Let's put it in for this one. All right? So it's 5 times what? 2 plus 2. 5 times 2 is 10 plus 2 is 12. So this is 12. So LM is 12. Without doing any math whatsoever, what's LK going to be? That's going to be 12 as well. There you go. All right? So that right there is the answer that they want. It's not much different than what we've done in the past. Would you agree? Okay. The only thing different is we're dealing with a kite. And we haven't talked about a kite until yesterday. But really, the whole idea of doing this problem, setting them equal to each other, solving for x, plugging it back in, we've been doing that since the beginning of the year. All right. So that process should be pretty familiar to you. Yes? Was it familiar? Yeah, absolutely. It should be. All right. Enough of that. Let's learn something new. Actually, I'm going to skip. There's an example where you have to do the distance formula and slopes and all that. It's your lucky day. I'm going to skip that. I'm going to go right to this next thing. All right, here we go. Everybody ready for new stuff? Because that's old stuff right there. That was yesterday's stuff. Now we got something new. And we have a name for it. To me, this is kind of interesting. This is one of those things, I teach a lot of different stuff. And some things, it's kind of boring. It's not that exciting. But I kind of like this part. This thing right here that we're going to do, I think is pretty interesting. I think it's kind of practical, depending on what you're doing. It's called the quadrilateral angle sum theorem. All right, let's take a look at this right here, the angle sum. We've learned already in the past, we've talked about triangles a lot so far, haven't we? So we learn about a triangle. So I'm just going to draw a triangle. I'm not going to make it fancy, just do it by hand. So what have we learned about the angle sum of a triangle? There's something that we've learned. You probably knew this before you even walked into geometry class the first day of school. What does it mean, the angle sum? What does that word sum mean? What do? You add them up, right? So I add up all the angles. So what happens when I add up all the angles of a triangle? What do I get? That's right. The sum angle, or the angle sum, let's call it that. Let's call it the angle sum of a what? Triangle is equal to what? 180 degrees. What does that mean? That means if I take this angle, and if I take this one, and I take this one, what do they all add up to be? 180. Does that mean this angle is 180, and this one's 180, and this one's 180? No, obviously not. All the angles in that triangle have to add up to 180 degrees. All right. But that's not what this lesson is talking about. This is not the triangle angle sum theorem. What is it? It's the quadrilateral angle sum. So what I'm going to do is I am going to draw any old quadrilateral. It's not going to be a special one. It's not going to be a rectangle. It's not going to be a square. It's just going to be some random looking four-sided figure. Okay? All right. Everybody with me on that so far? There's a quadrilateral. Is it a parallelogram? No. Is it a trapezoid? No. Is it a kite? No. It's just any four-sided figure. That's all it is, okay? But watch what I'm going to do. I want to find out what all the angles add up to be on a quadrilateral. And you might already know it off the top of your head. Any idea? Just off the top of your head. If I told you to add up all the angles of any four-sided figure, what do they add up to be? Anybody know off the top of their head? Say it, Cabry. You just said it, I think, didn't you? 160? 360. 360 degrees, right? You've heard that word before. My son is into, it's not skateboarding, but he does the scooter thing. You know what scooters are? You know, it's got the two wheels, and they go to skate parks and stuff, and they do all this stuff. He actually went out to California to live. He lived in a house with a bunch of guys that were scooter riders, and that's what they would do. They would go out. They used to do it here in Delaware. They would go up to Philadelphia. They go up to Philadelphia, and they call it a street jam, and they would have like hundreds of these kids on scooters, and they go up and down the streets of Philadelphia, and they'd find, you've probably seen skateboarders do it, right? But they find these railings, you know, these handrails, and they slide down the handrail and all that kind of stuff into the street, all that thing. So anyway, but something in there they do like a 360, right? So what does that mean to do a 360? You turn what? All the way around, one rotation. But then they do other ones, right? Like a 1080 and a 720 and all that kind of stuff, right? You probably heard that thing before. So 360 is a number that's kind of, you know, stuff that we know. We know what that means. But it's absolutely true that the angle sum is 360. Why is it that? Well, I'm glad you asked, because I'm here to show you. Did you ask? Maybe. Watch what I'm going to do. I'm going to draw a thing called a diagonal. That means I go from, have we done diagonals before? I can't remember. So here's the first one. Watch. I go from one vertex, we have talked about vertices before, to another vertex, but not to the one next to it. Everybody see this? Diego, watch it. Okay, so watch. I'm not going to go to this one. I'm not going to go to the one that's consecutive to it or right next to it. I'm going to go to a non-consecutive, like right there. Now, what did I do? I broke that quadrilateral up into two what? Two triangles, right? So I got a triangle here, and I got a triangle here. Yes? What did we just say about all the angles? What do all three of these angles add up to be on this triangle? You're just saying things. You're not thinking first. Think. I appreciate your enthusiasm for answering questions, but you're not thinking though, okay? Listen to what I said. This is a triangle, okay? What do all the angles of a triangle add up to be? I've heard it. What is it again? It's 180. So this is 180. So this triangle, this skinny little triangle right here, all the angles add up to 180. Would you agree? What about this second triangle? This kind of fatter triangle right here. See this one? What do all those angles add up to be? 180. Everybody see it? So look, I got this angle, this one. I've got this skinny one right here, this one, and this one right here. The angles here add up to 180. The angles here add up to 180. So what? In the whole entire thing, what do you think all the angles add up to be then? 180 and 180 is what? 360. That's right. So the angle sum of a quadrilateral is always equal to what? 360 degrees. That wasn't hard to see, was it? Pretty simple. So if I just drew a diagonal, it broke it up into two triangles. This is 180, that's 180. So altogether, the whole entire thing, the whole entire quadrilateral is going to be 360, because 180 and 180 is 360. Everybody understand that part? We're going to go a lot further than that, though. That's the first part. So watch what we're going to do. What if I asked you to find the angle sum? Again, what does that mean? When I say find the angle sum, what am I asking you to do? Find out the Sum, what does that mean? What do we do to all the angles? Add them all up. That's right. If I add up all the angles, okay, to this particular thing, figure, polygon, what's it going to be? So let's keep a little running list here. So if I have 4 sides, how many triangles did I get when I drew that diagonal? How many triangles did I get on that last one? Okay, 2 triangles, correct? Let's push this over a little bit, so running out of room. We're going to keep a little running list here. We're going to look for a pattern, all right? We're going to look for a pattern. So I got 4 sides, gives me 2 triangles, and that gives me 2 times 180, which is what? 360, okay? 360 degrees. What if I had 5 sides? Now, I haven't done enough to find a pattern just yet, so let's draw something with 5 sides. Again, it can be any kind of random 5-sided figure, all right? So it's going to look, there's 1, there's 2, there's 3, there's 4, yeah, it doesn't matter, and then it's 5, okay? So it's 5 sides. So what did we do on that? What's the first thing that we did on that quadrilateral? I drew a what? That red line. What did I call that red line? A diagonal. So what I'm going to do here, I'm going to pick any vertex. It doesn't matter what vertex you pick. Let's pick this one right here, okay? I'm going to draw as many diagonals as I can from that one vertex. You guys are talking, you're not paying attention. Diego, please. All right? It's like the 4th time I've had to look at you. Please pay attention. So if I start right here, I'm going to draw some diagonals. Don't draw it to the one that's next to it, okay? Draw to one of the other vertices. Where can I draw it? Well, I could draw it to right there, couldn't I? But this one's not a triangle, is it? I'm going to go from that same exact vertex and draw another diagonal. Where am I going to draw that one? To right there. You see that? Can I draw any more diagonals? Nope, because the only place I could draw is to the vertices that are next to it, and that's not a diagonal. So how many triangles did I make now? I got 3. There's 1, there's 2, there's 3. So, whoops, if I had 5 sides, how many triangles did I get when I drew the diagonals? I get 3 what? 3 triangles. So, how can I find the sum of all the angles inside that pentagon, that 5-sided figure? 3 times, good. 3 times 180, and that gives you, what's that, 540? I should have these memorized. I really should. I've done this enough, but sometimes I don't. Let's do another one to establish a pattern. Two things are not enough to establish a pattern. We need at least 3, all right? So let's do another one. And I'm just going to erase this and do another one. So how many sides am I going to have this time?
6.
We're going to do a thing with 6 sides. By the way, what is it called when you have 6 sides? What is it? Well, polygon's any number of sides. What's specifically 6 sides? Octagon is 6 sides. I know you're doing it just to, believe me, I hope you're doing it just to irritate me because it's a hexagon. So again, this could be any random hexagon. It doesn't have to be anything particular. So 1, 2, 3, 4, 5, 6. All right? So there's a hexagon. What's the first thing I'm going to do? I'm going to draw what? Diagonals. Okay, I can start from any vertex. It doesn't matter where I start. Okay? Seems like I've always started at the left. Let's start somewhere else. Let's start right here. Okay? I'm going to draw diagonals. I don't draw to the one that's next to it. I draw to one that's not next to it. Right there. A non-consecutive vertex is what they say. Fancy name for it. I go from the same exact vertex and I go to another vertex. I go to here. All right, it's not hard to draw diagonals. And then I go to the next one right there. Can I draw any more diagonals from that one point? No, I can't draw it to here because it's right next to it. I can't draw it to here because that's right next to it. But I can draw those 3. So how many triangles do I have now? Let's count them up. I got 1, I got 2, I got 3, I got 4. So I've got 4 triangles. I'm starting to see a little pattern developing here. Do you? So if I got 6 sides, how many triangles am I going to have? I'm going to have 4 triangles. And how do I find the sum of all the angles of that? I go 4 times what? 180, and that equals 720. I could keep doing this all day long, all right? But I'm not going to, don't worry, all right? But let's just kind of guess. Let's kind of guess. What if I had 7 sides? Instead of drawing it out, what do you think? It's 5. How'd you get 5? Because what do we do? Yeah, 2, 3, 4, 5. But what do we went from 4 to 2, 5 to 3, 6 to 4. Up 1? Look, I said don't look at it as 2, 3, 4. Look at it as from 4 to 2. What did I do to 4 to get 2? What did I do to 5 to get 3? What did I do to 6 to get 4? What? Half? Is that what you said? Did we take half? Half of 5 is 3? No. Half of 6 is not 4. What do we do? It's something very simple. Subtracted 2. Thank you. I thought everybody would get that right off the bat. Look, we went 4 minus 2. We went 5, what? Minus 2. We went 6. Talk to me. Minus 2. So what's this going to be? 7 minus 2, which is 5. That's a key. That right there, that minus 2 thing is huge for what we're going to talk about in a second. All right? So it's 5 times what? 180. I don't know what that is off the top of my head. That's that plus 360. So, no, it's like, what is it? Is it? I should know it off the top of my head. 180 times 5 is 900. Okay? So it's 900. That's not one that I use all that often. Okay, let's continue the pattern. I'll do a few more, okay, just so you can see what's going on. I want you to see the pattern. So if I have 8 sides, what if I have 8 sides and I draw the diagonals from a vertex? How many triangles am I going to get? 6 triangles. And so how do I find the sum of all the angles? I go 6 times what? 180. And that is, I believe that's 1080, isn't it? Or, no, it's not. 6 times 180. How do I not know that? Yeah, it is. It's 1080. Oh, yeah, 1080. I was thinking of adding 360. That was weird. I was wondering why my math was off. All right, so that's 1080. Let's jump down to 10 sides. Okay, well, we don't see 9 very often. We see 10 quite a bit. So what if I had 10 sides? How many triangles would I get if I had 10 sides? Jude, if you're not going to answer correctly, or not just correctly, but with good faith, don't throw things out, okay? It's just disturbing everybody. So I got 10 sides. How many triangles am I going to have? I'm going to have 8. Look, I jumped from 8 to 10. I said I wasn't going to put a 9 in there. All you're doing is you're going 2, 3, 4, 5, 6. What I want you to see is not 2, 3, 4, 5, 6. I want you to see 4 minus 2, 5 minus 2, 6 minus 2, 10 minus what? 2, which is 8 triangles. And then what do I do to find the sum of all the angles of a 10-sided figure? I go what? I go 8 times 180. And that's 1440, I think, isn't it? Yep, 8 times 180. Yep, 1440. So some of these numbers I do remember. There we go. All right, what if I had this? Now watch very carefully. I want you to think about this. In math, we use letters to represent numbers, correct? We do it all the time. We did that. You learned that in Algebra 1. We're going to do that here. What if I had n sides? What does that mean? That means it could be any number of sides. That's right. Okay? So n represents any number. So how many triangles am I going to get if I have n number of sides? No? Because that would mean if I had 10 sides, I'd have 10 triangles. If I had 8 sides, I'd have 8 triangles. But I don't. What did we do? Again, let's do the pattern again. I went what? 4. What math did I do? 4 what? Minus 2. 5. Talk to me. minus 2, 6 minus 2, 8 minus 2, 10 minus 2, n what? Minus 2. You got it. So it's n minus 2 triangles. That seems weird, but what does the n represent? It represents any number of sides. So if like I had 100, if I had a 100-sided figure, okay, I don't even know what the name of that would be, but if I had a 100-sided polygon, how many triangles will I get out of it? I'd get 98 of them. That's right. And then, so what would this be? This would be what? N minus 2 times what? What do we do? Every single one of these. We took how many triangles we had and multiplied it by 180. That number right there is really important. So here we go. We are ready to write our little formula. We kind of came up with our own formula. This is the angle sum of a polygon, of any polygon. Okay? So how do I find the angle sum of any polygon? I take the number of sides and I do what to it? Minus it by 2, subtract by 2, and then do what to it? Multiply it by 180. That's it right there. That's your formula. Now, I could have saved a lot of time, and instead of drawing all those diagonals and going through the pattern and all that kind of stuff, I could have just said, how do I find the angle sum of any polygon? Here it is, right there, n minus 2 times 180. And you'd probably be looking at it thinking, where did that come from? Would you agree? If that's what I did right off the bat, you probably wonder where that came from. And most of you probably wouldn't care where that came from, to tell you the truth. But I do, and I think you should care. All right? I think it's important for you to understand where that came from. So we kind of developed that formula ourselves. We went through this whole thing. We saw a pattern. We're like, if it works for all those, it must work for any number of sides. All right, so what do? Take n minus 2 times 180. So let's use it. Let's actually put it into practice. Yes. So let's put it into practice. What if I told you you had a polygon with, whoops, it's not a polygon, it's a polygon. What do you need? Tissue. Is there, here's, right there, paper towels. I don't have tissues, but I got paper towels. What if you had a polygon with, let's say 12 sides? What is the angle sum of that polygon? What's the angle sum? Again, what does that mean? That means if I add up all the angles, if I had a 12-sided figure, okay, and I added up all 12 angles, what would they add up to be? That's what I'm trying to find. You understand what I'm finding here? It's the angle sum, the sum. When I add up all the angles to that 12-sided figure, what is it going to add up to be? So, what's my little formula? What do? 12 minus 2. Very good. I go 12 minus 2 times 180. All right? And then you just work it out. What's 12 minus 2? It's 10. Now, this one's an easy one. I can actually do this one in my head. What is that? It's not 1,800. It's 1,000. Well, it's 1,080. And then what do when we multiply by 10? Stick a 0 on there, okay? So that's how many degrees. Yeah, why did I do that? Well, that was silly. I was thinking, I don't know why I did that. That was dumb. But thanks for catching me on that. Okay, there we go. Multiply by 180. I was thinking the 1080 from before. It was stuck in my head, and I just wrote it down. Don't know why. But you're right. This is what it's supposed to be. So, who said 1,800? You got it right, okay? So, it's 180, and then multiply by 10 is easy. Just stick a 0 in there. So, that would be 1,800. I was looking at that big number. I thought, wait a minute. That's way too much. All right, so I'm glad you corrected me. So that's how many degrees. Does that mean every single angle is 1,800 degrees? Of course not. Okay, if you add up all 12 of those angles, what do they add up to be? They add up to be 1,800. All right, let me go one step further and we'll be finished, okay? We got 5 minutes, so bear with me. I know I've been teaching a long time today. You guys have relatively, for the most part, have been pretty good. So what I want to do is I want to do this. I'm going to make a polygon, and I'm going to make it, I got 6 sides right there, so let's do it like this. Now, this particular one right here is kind of a special polygon. It's not just any old polygon. What does it look like might be true about all 6 of those sides? They're all equal to each other. So let's mark them. So that's equal, equal. All right? So what do you think is going to be true about all those angles in this situation? They're all the same, right? They're all equal as well. So every single one of these angles, I'm going to mark them. There's only 6 of them. Okay? So every single one of these angles are equal to each other. We've talked about this earlier in the year. We gave it a special name. If all the angles are equal to each other and all the sides are equal to each other, we gave it a name. Yeah, you could call it equilateral, but that just discusses the sides. Silas? It's not congruent because we would compare 2 things to each other if they were congruent. Okay, it's both. So you're half right. The equilateral and the equiangular, you're half right. What if you put them both together? What if something is equilateral and equiangular? I think we've talked about this. Maybe we didn't. I thought we did. It's called a regular polygon. We never said that? Okay, my bad. I've taught this stuff to 2 other classes earlier in the year, and it's hard for me to remember what I said in each one. But that's what it's called. But I'm glad you guys said equilateral, and I'm glad you said equilateral and angular, okay? But if you put them together, if they both have the same sides and the same angles, then it's a regular polygon, all right? It's very special. To us, it seems like regular is just like an average one, but it's not average. It's a special type of polygon. Now, let me ask you this. We've already done this. It's probably already in your notes, but let's do it again. What is the angle sum? What do all 6 of these angles add up to be? Well, how do I find it? How do I find that? 6 what? What's the angle sum? 6 minus 2 times 180, correct? 6 minus 2 is 4 times 180. What's that? 720, right? Isn't that in your notes? Didn't we do 6? Yep. So all these angles add up to be 720 degrees. But guess what we're going to do now? We're going to find what each of these angles are equal to. You know they add up to 720, but I want to find what every single one of these angles is equal to. Exactly right. You got it. You take the 720 and you do what to it? You guys aren't even paying attention. So you take all the angles. How many angles are there? 6 of them, right? And if they're all exactly the same, like if I had $720, I don't have it, okay? Don't even have anything close to it. Probably don't even have that in my bank account right now. I don't know. All right, but let's say I had $720 and I picked 6 of you and I was going to distribute evenly $720. So what would I do? What's the math that I would do? Divided by 6. That's right. I go 720 divided by 6. All right? And what is that? 72 divided by 6. What's that? Right. So that's 12 and a 0. So it's 120 degrees. So what we just found right here, you can only do this with regular polygons. Okay? If all the angles are not equal to each other, you can't do this. All right? You can only do this when all the angles are equal to each other. So what do? We found the angle sum, right? So this is the sum of the angles. This right here is what? Each angle. All right? So each angle is 120 degrees. So that's 120, that's 120, that's 120, and so forth. Okay? That's really important. So what if I asked, real quick, a stop sign. Let's say you pull up to a stop sign, you have a little protractor, and you want to find the angle of a stop, the angle that the sides of the stop sign make. Let's do this real quick. So what do? You go 8 what? Minus 2 times 180. All right, and what do you get? You get 6 times 180. I think that's 1080, right? And then, how do I find each angle now? Divided by 6? 8, because there's 8 of them, and that I think is 135. So if you pull up to a stop sign and you have your protractor and you measure the angle that it makes, don't do that, by the way, all right, you're going to find out that it's going to be 135 degrees. I got a little bit more to do, so I'll give you some more stuff tomorrow.